Hey everybody, welcome to the second episode of the Under the Hood live stream. While I was on my way back here to the office, I went by bike. I'm Dutch, obviously, so it's summer. There's like quite a few bugs outside, and one of them decided to fly in my nose. And not like a little bit, but like all the way up there. You know, there's this tube that connects from your nose to your throat. I think it ended up somewhere in that tube. It's pretty disgusting, to be honest. The problem is, I'm not 100% sure it left. It might actually still be there. I don't know really why I'm telling you this. Obviously, you didn't come for that. You're coming for the live stream where we're going to talk about code. So I'm going to do the code review, possibly with a bug in my nose. The show must go on, right? The way that this works, so I did an episode of this Under the Hood series before, is that I have 3 envelopes here, A, B, and C. And each of these contains an open source project. I'm going to randomly pick one. So I have no idea what project we're going to take a look at. We're going to find out in a few minutes. And already just to get started, perhaps I can already run a random number generator or random character generator in Python and see what happens. All right, so it seems we are going to take a look at envelope A. Really exciting. Now, before I open this envelope, we worked over the past month really hard on my software design course. So this is like one of the very first courses that I made is the software design and mindset. And I thought it was time for an update since the video is already quite old. And well, I've also learned a lot of things myself in the meantime, and I wanted to completely update the course. Now, if you already bought the course, then this is going to be an update that you're going to get for free, especially if you got the complete version of the course. Actually, it's a pretty big update. There's lots of extra material. All of that will drop in the coming weeks. Because of that, I am going to increase the price of the course in September. So well, if you still want to join, well, the price is lower, and then of course you also get access to the updates, then actually now is a great time to join. I'm going to share more details in the newsletter in a few weeks, but if you want to take a look at the course, this is at arjan.codes/courses/tsdm of the software designer mindset. So anyway, let me open the envelope and see what's inside. What are we going to take a look at this time? Very exciting. All right, can you read it? Can you read it? Requests. We're going to take a look at the requests library. That's going to be interesting. And pretty low level, so actually also a bit scary perhaps, but let's see. So what I am going to do is, just a minute, I'm going to look up the request library on GitHub. And then I'll switch to my browser and then we can take a look at the code together. All right, so here's the Git repository for the request library that we're going to take a look at today. The way that this works is I'm basically going in completely blind. I haven't taken a look at this code. I have no idea what we're going to find. So that means I'm probably going to miss things. I'm going to make mistakes. There's basically going to be no filter to my reaction to the code. And hopefully we're going to find out some interesting things. But I also hope that, well, on the one hand, this is going to give you an idea of if another coder looks at a project, what are the kind of things that they think about, but also that open source projects like Request or like most of the other Python packages are just done by normal people like you and me, and you can contribute to that, and it's not magic. So if you notice yourself anything in the request code, so feel free to open also a browser on your machine while you're watching the stream and browse the code a bit. And if you see something interesting that you'd like me to take a look at, or you have some specific question or suggestion, just post it in the chat, and then I can also navigate there and see if I can answer your question. And finally, what I'm going to do, I actually forgot that the last time, but now I hope I won't forget it, is that I'm going to give the project a rating. And in fact, this time around, I'm not going to do the rating, but I'm going to post a poll in YouTube, and I'm going to let you give a rating between 1, which is the most horrible design ever, and 5, the best thing since sliced Dutch bread, which is, you know, a high bar. So let's start by taking a look at the actual library and see what is going on. So it's always a bit interesting to see where we're supposed to start with this. I'm just going to randomly browse around a bit. So I see there's some documentation here. So how does that actually work? Probably don't want to spend too much time in the actual documentation, but yeah, so this is kind of, oh, okay, there are no authors. Interesting. All right. Maybe I shouldn't look for it in the actual documentation, but look at the actual source and the test. So one thing that you see in a lot of these packages is that you're going to have separate source folder and you're going to have a separate test folder. So let's actually take a look at the test folder and see what is in there. So what's actually nice is that there is, yeah, there's quite a lot of test files here. So that does look nice. I think a problem with a package like request is that you need to be very careful with how you test this, because obviously this does request over the internet. So you need to like mock that out, and maybe later on we can take a look and if we can figure out how that actually works in the tests that are set up for the request package. Now, maybe before we do that, I think it's good that we have a better understanding of the actual source code. So let's take a look at what is in here. And the last time I did a review of the Faker package, and there was all sorts of stuff in the donder init file, which kind of confused me in the beginning. So maybe we start there and take a look at what this actually is. So there is some documentation here about what the request HTTP library is. There's imports. If anybody has any idea what this is supposed to do, charset normalizer. I have no idea what that is actually supposed to do. It's interesting. Oh, see a question from Amir, will this be saved? This is a live stream on YouTube, so you can actually watch it later as well. Doesn't mean you should leave, of course. Please feel free to stay and ask any question you like, but this is going to be staying on YouTube, so you can also watch this later. All right, so let's see. There is a function for checking the compatibility. I think that's also an interesting thing about open source projects like this. So request is, of course, widely used, and there's often a lot of extra boilerplate code around versioning and those kind of things, because of course you want this to work in the widest variety of settings possible. So whenever you have a big open source project like that, chances are that you're going to see quite a few of these compatibility things. So that's interesting that this is actually also part of the request package. So it seems to be that this is mostly that. So there is so this is about compatibility. Check compatibility. If you scroll down, you see there is more compatibility things like the cryptography version, the other dependencies. So really compatibility things that are in the donder init file. So that's interesting. Okay, so I don't see any really surprising things here. I mean, you could potentially say in terms of design, well, maybe check compatibility is, you know, quite large. So you could perhaps split this up, because it seems, for example, that this if statement checks various types of compatibility. So you could split this up into separate functions if you wanted to, but it's not really a big deal. All right, let's see what else we have here. So there is an internal utils. That's also always quite interesting to see what's in there. So some regular expressions. This seems to be validators for headers. And what else do we have? To native string, given a string object, regardless of the representation of the string in the native string type. All right, so this does optionally it does a string decoding with a particular type of encoding. Okay, then Unicode. Yeah, so I mean that also makes a lot of sense in a package like request. Of course, you are communicating via HTTP request, so there's you need to make sure that the strings you're passing are in the right encoding. So these seems to be aimed at that. All right, then let's see what else we have. Adapters. Would that be a design pattern? That's interesting. Okay, so adapters. This module contains transport adapters that request users to define and maintain connections. Okay, lots of imports. Let's scroll down and see what is actually going on here. Let's see. Okay, so we have some function, no idea what this is actually doing. Lots of arguments, or actually that's not that many, 4, but we don't really have an idea what this is going to do. I think, well, one thing that you see that there's a lot of dependencies on urllib3, which is probably the low-level thing that requests users to communicate via HTTP request. Perhaps we might also take a look at the urllib3 documentation, so we have a kind of idea of what it's actually doing. So yeah, this is a HTTP client, and so this does things like connection pooling, SSL verification, multi-part encoding, stuff like that. But it is a pretty low-level library, right? You typically want to use, if you're doing, let's say, interact with the REST API, you want to use something like request or HTTPX. If you want async communication, then, and that will probably also rely on something like urllib. Although there is actually a way to do directly request with urllib3 like this, but I'm guessing request adds a bunch of functionality on top. So anyway, don't want to dive too much in this particular library, but let's go back to the request source code. So this is still the adapters.py file. One thing that I do notice is that, well, these type of functions, they are actually quite large. I think it would be helpful to split this up into various parts, especially if you see these multiple if-else statements. I would look if I could somehow reorganize the code so that this is a bit cleaner. Let's see. This is also interesting, by the way. This is a comparison with verify to check that it is the Boolean value false. What's actually interesting about this is that true and false in Python, they're actually integers, but they are integers with a is stored in a cache with a fixed ID. And this is operation in Python actually compares the IDs. So this checks actually that verify points or refers to the object with the same ID as false or as true. So this is not a direct Boolean comparison. I expect they do this because it's possible, maybe, that verify something else than Boolean. Yeah, you see right here. So it can be a Boolean, it can be a string, it can be none. In my opinion, that is not a really good way to do to design it. I typically don't really like to use arguments in functions that can be all sorts of different types, and then depending on the type, it has different behavior. So let's see what actually happens here. So if it's false, then there is no certificate. If it's true, then it loads some SSL context, and if it's a string, then it's actually, I guess this is the directory of the certificate. So the argument verify is actually used for multiple things. A, whether there should be a certificate, and B, if there is a certificate, you can use it to define the path of the certificate. So I would actually recommend to split this up into 2 things so that it's clear what each of these means. And then you also don't need to do all these checks here, because then you know what the type is, and that makes it a lot easier. It might also be a question of in like older code like this, that you see a lot of these is instance things. I think that's also a bit before. Why is this opening all the time? I think that's also a bit before, let's say, typing became a bit more popular in Python. Nowadays, I'd say it's a good practice to rely more on typing instead of checking the instances everywhere. It saves you on if statements, make the code a bit shorter. So if I were to like refactor this code, I would probably see if I could define the types in a function like this more strictly, and actually not have all these is instance checks, but organize it a bit differently. Question, love, what open source project are you reviewing? This is the requests package. You can also see it here at the top of the browser. So that's requests. Lots of people use that for HTTP and API requests. All right, let's see what else we have here. So there's a class. Now we're going to come to the adapter part. So we have a base transport adapter. So this seems to be the part of the request system that's responsible for dealing with where the content or where the request goes. So there's a stream parameter. We have some other options like timeout. Again, the verify parameter, which is either a Boolean or it's a string. In that case, it's a path. Let's see. And another thing you can see here is that the base adapter has not implemented errors. So this serves as a base class for all the other adapters. And then, for example, here we have an HTTP adapter. That's a subclass of base adapter. So this inherits from that class, and this provides then implementations for the send and close methods. And let's see what's going on here. So this seems to be a wrapper around the URL lib3 HTTP adapter, or the URL lib3 code. So let's see what actually happens here. So there is some internal instance variable that contains some values, max retries, config, pool connections, okay, some low-level stuff. I'm not really sure what all of that is for. Let's see what else we have here. So this is the initializer. So here, the things like the max retries are set. Oh yeah, this, okay, so this is the attributes done. Okay. I'm not sure why they defined it this way. It might be because this clarifies when you look at the top level of the class, so you know immediately what the attributes are going to be. So that's max retries, config, pool connections, etc. In a sense, that's nice, because otherwise you'd have to go and go through the initializer and figure out what is going to be set on self. So this is actually a nice way to do it. For me, also often that's a reason to use data class, because then you can also see at the top immediately what are the attributes that a class has, and you don't have to look in the initializer. And then we have some helper methods like getting a state, setting a state. So this seems to have something to do with the connection pooling. And then a bunch of other methods. Let's see, what else can we, yeah, so there is this returns a URL lib3 proxy manager. All right, yeah, I'm not 100% sure what this does exactly. It seems that it also maybe works with sockets or something. I must admit, I'm not like a network guru or so my knowledge of this kind of stuff is kind of limited. But again, I do see a kind of issue here with like pretty large if-else statements. So this looks like you could potentially simplify this by splitting this up into a few different functions. Each handles the different case in the if-else statement. All right, then certificate verification. Okay, this verifies an SSL certificate. So let's see, there's also here a pretty large if statement. Again, so I think this is similar to what we've seen before, that there's often these two cases where either there's a certificate, you are dealing with an HTTPS connection, or you're dealing with a regular HTTP connection, and then those two cases need to be handled differently. It might even be nice to actually split that up into two different adapters, so that you would have an HTTPS adapter and an HTTP adapter, instead of having one huge adapter that does all of it. I'm not entirely sure, maybe that's overcomplicating things. But that does mean that now we have a pretty large if statement here, and we have to deal with these two cases. And again, this is repetitive, because here we check whether we're dealing with HTTPS, and then we do all this stuff. Else we do this. Then if we have a certificate, then we do all of this. So it seems to me that not splitting up HTTPS and HTTP in different adapters leads to more complicated code. So that might be something that we could improve potentially. Just going back to the chat for a minute, I think you asked a few questions. So I see a question from Luciano. Can you show how else you would compare types other than using is instance? Yeah, so actually the way that you would normally do this is that actually you don't have to compare these things at all, because the interpreter already takes care of this for you. Perhaps I can switch quickly to my code editor and show you an example of what I mean. So let's say I can just work directly in this. So let's say you have some function, and that function gets an integer, right? And then it returns x plus 1. So if I define a main function where I then just print the result of calling that function. Let me remove this because we don't need this. And let me also add a call to the main function. So if we run this, obviously this is simply going to print 2, right? Pretty trivial example. But here the idea is that because we specify the type, we don't need to check for what instance this is. So let's say if we go back to how it worked in the request library, we had a boolean or a string. So that would be something like this, right? So if you do this, then you have to do an is instance. If it's that, and then else, if it's a string, then we can do something else. It's like completely meaningless what this actually does, but you know, just to give you an idea. And then here we can now pass, for example, true, right? And then this is simply going to print, well, 1 in this case, and I can change it to a string, and then it's going to do something else. And this this works because we've specified the type in this way, but we still need to do the is instance check. What I mean by being more strict with type is that you typically don't, I think in terms of design, it's actually bad practice to have different behavior based on the type of something. I think instead of doing this split, I think it's better to have 2 arguments. So if we change this to, let's turn this into something that looks a bit more like it works in the request library. So this was a check for a certificate, right? And that was going to be a boolean, or it was going to be a string. And if it's a boolean, basically, if the certificate is a boolean, then there was a check that if certificate is false, then let's print there's no certificate needed. I'm going to change this to none, like so. And else, we're going to print that there is a certificate. And if it's a string, actually that doesn't need an else statement, so now it's always a string, then we would print certificate hardware path. is this. And then we're simply going to call that function. So now we're getting this. And now if we pass like a path, like, I don't know, user, whatever, it doesn't really matter, right? Then it's simply going to print the path. So that's kind of how it's set up in the request library. My point is that I don't really like this, these is instance checks, because now, you know, we have different types. This thing can have multiple meanings. I think from a design perspective, that's not really good. So what I would do is have a certificate Boolean value, and then I would add a second parameter here, like a certificate path, for example. Let's use a string for that. And we could actually turn that into an optional string, like so. And now let's also import that from the typing library. There we go. So now, how would it look like without all these if instance checks? So now we know certificate is Boolean, right? So what we can do now is I can take all of this code. Let me de-indent that. So, oh, that's actually not necessary. So we check if there is a certificate, else then we have a certificate path, right? Like so. It's kind of a rough example, but what you can see, like if we run this, so now this still works, is that actually the logic here becomes easier because we have these two arguments, and we always know what kind of thing each argument is. We don't have to deal with if instance checks, and this, in my opinion, this is easier to read. You can also, of course, rewrite this now, because if we know it's a Boolean, we don't have to do this, let's say, arguably non-standard check, and then we simply return, and now it becomes a sort of guard clause, and then you have this. So in a sense, what the code that we ended up with here, in my opinion, is simpler to understand than if you have one argument that can be of various types. And this is just, of course, a very simple example, but if you have, let's say, a function which has multiple arguments that each can be multiple types, you're going to end up with a whole bunch of if-else statements and combinations that you need to check, and with if-is instance checks and whatnot, and that's going to lead to code that's overall, in my opinion, a lot harder to read. So let's see if there's some other questions that I can look into, and then we continue looking at the rest of the code. So Sergey says, why in this library it uses double quotes for the type hints? So I think that has to do with compatibility, that not all, especially in older versions of Python, type checking is more limited than in newer versions. And also there is often an order issue where if you use a class type before, or you use it before you actually define it, then the IDE might not recognize it. You may run into all sorts of different issues. You can actually avoid that by, I think, importing annotations from future, which nowadays is no longer the future. So it's all a bit messy, and I think that's why many libraries actually just use a double quotes, because then that's basically a message to Python to say, hey, we're using this type hint, but we don't check what it is. We know what we're doing. Let's see, Dustin, why not just use certificate path, and if the path is none, then there is no certificate? Yeah, that's also another way to do it. So then you don't need the Boolean value, and just if you supply the path, then it's there. But I think the thing in the request library, why they probably do it like this is, let me look up the code again where the check is for the certificate verification. Yeah, I think there is some different behavior depending on whether it's a directory or not, and then I think that's maybe why they decided to do it like that. I'm not entirely sure, but frankly, I see there's lots of checks here. There is a check for whether it's a base string. It can be a Boolean. I think, in my opinion, that's a bit messy. But anyway, I want to continue with and not just look at this part of the code, but let's also explore a few other things. So let's see if there's other adapters here, or do we only have the HTTP adapter? Okay, it seems we only have the HTTP adapter. So this is a good example of actually a design pattern, right? Because what this does is that, well, probably in other parts of the code, we're going to see that the request library, hopefully they did that the request library is going to refer to this base adapter class and not to the HTTP adapter. So in my opinion, in terms of design and code organization, actually, HTTP adapter should not be in this module. I think there should be a separate module, HTTP adapter, that contains the specific implementation. And base adapter, that should be part of the core system of request. But we're going to find out if we see whether there is a reference to the HTTP adapter in other places, because normally there shouldn't be, or maybe there should just be on a very high level where the request library is set up. All right, so let's take a look at the API. It's also interesting. Okay, this implements the request API. Let's see, what do we have here? So this actually contains the request function. So this gets a method, it gets a URL, it imports sessions. Let's see what sessions actually contains. Okay, so this contains the session object. All right, so maybe we'll take a look at that a bit later. But let's take a look at the request function. So that gets, of course, a method, get, post, put, etc. And it gets a URL, and there are a bunch of keyword arguments. And then we have lots and lots of parameters. Okay. So this does nothing more than basically create a session and pass that to the request method of that particular session. I'm not a big fan of this kind of setup where we have here just a couple of, arguments, and then there's like a crap load of keyword arguments that can be basically anything. To me, this is a bit like a kitchen sink kind of function that has like a ton of different possible parameters, and it's not, you have to really dive into the documentation of the function to figure out what those parameters actually can be. Now this is probably like a lazy way of allowing for any number of arguments to add to a request function call. But I think it's important to be more precise, and I think it will be helpful to actually have the actual arguments to the request function mapped out here. And of course, that's a bit more work because most of these things, they're all going to be optional, right? So that means you need to use the optional type. I'm not sure from which version that was actually added to Python, so maybe that's also a compatibility thing. But whenever I can, if I design a function and I think about the header and the arguments that I need, I try to avoid using this kind of generic keyword arguments setup. And of course, also here, type annotations are missing. So it would be helpful to know that these things are actually strings. But I want to figure out what is actually going on in this request function of the session class. So let me go to the sessions file and we take a look there. All right, so here there is lots of imports, including the HTTP adapter. That's interesting. Why is this an HTTP adapter? Where is that being used? It's being used twice. Okay. So that is in where is this? In the session class, which is a subclass of session redirect Mixin. Okay, we'll have to take a look at that a bit later. But this actually creates an HTTP adapter. Okay, so this actually defines the default connection adapters. So this is interesting. You know, I mentioned a couple of minutes ago that I thought it might be nice if we had separate adapters for HTTPS connections and HTTP connections. And here, I think this is a good example where you pay the price for not doing that. Because each of these, for these type of adapters, they both are an instance of HTTP adapter, which I find strange. Because now we have to create these two objects. And within the objects, we have to make the distinction between whether something is an HTTPS or an HTTP connection. And that leads to lots of extra if statements. So I think this is another argument, at least in my opinion, for using two classes. Another thing is that session seems to be something generic. It's a request session that provides all of these common things that you want: cookie persistence, connection pooling, configuration. I think it would be better if session didn't create these very specific adapters. I mean, obviously request is aimed at having HTTP connection, so it kind of makes sense that it does. But then if that's the case, there's no need for a base adapter class. So think as a developer, you have to choose. Either you introduce the abstraction, and that means you create a base adapter class. But then you have to be consistent with it. And that's the class that you use throughout your code. So then session shouldn't know about HTTP adapters. Or you abandon the idea of abstraction. And in that case, well, then you can use the specific classes because they're a core part of your library. And I feel like that choice is not clear in the design at the moment. I don't know. Let me know what you think about this. Do you think sessions should create HTTP adapters? Or do you think sessions should be a generic thing that is independent? And then there is maybe a simple setup where we create a session, we supply it with default adapters instead of session creating these things itself in the initializer. All right, let's see what else we have here. Okay, so we have request preparation. So this does some cookie-related things. There is some merging happening to merge the cookies with the session cookies. I'm pretending I know exactly what this code is doing. I'm not. I'm merely reading documentation, trying to figure out things as we go. Just to be completely transparent here. All right, so we have authentication. Yeah, so you see all these different aspects of HTTP, HTTPS connections come by here. So that's interesting. And then we have a prepared request. Where does that come from? Prepared request, what is that? Is that a class that's here or is that defined somewhere else? Okay, this comes from a models file. So that's apparently something that is defined somewhere else. Okay, fine. Let's see, what else do we have? Okay, I'm a bit lost now. Wait, I think I skipped over. Okay, yeah. So this is the superclass of the session. They call the Mixin, which is a bit weird because why? It's the only superclass, so I'm not sure why you would call that a Mixin. What's the reason for this split up? Why is there a separate class that's called Session Direct Mixin? Can we figure that out? Unfortunately, there's no documentation here. So let's see, there is a get redirect target. Okay, this should strip off. Okay, do we remove the authorization header? So this seems to be a helper method, and is that related to the get direct target? No, it's not. Where is that actually handled? The resolve redirect, that sounds like something that uses the other things. Yeah, okay, so this gets the redirect target. Where is the call to the, let's see, okay, so this does cookie extraction. It's a bunch of stuff that is happening here. Rebuild auth, rebuild proxies, just scrolling down a bit. Okay, and then we get to the session class. Scroll back up again. I want to find out where is this used. All right, that's used here in rebuild auth. Okay, so that's basically a helper method for rebuild auth. The question I have is, why would you define this as a class? Because if I look at the code, and maybe I'm missing something, if I look at the code and I see that I don't think any state is stored here. I don't think there's any state. No, not yet. Where is send defined? Is send defined in the session? I think we're going to find out soon. Yeah, okay. 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 So honestly, I'm not a big fan of mixins in general. I think they sort of abuse the inheritance principle. The inheritance idea is that you have a superclass and you have subclasses. So typically a subclass is going to be a kind of superclass. So if you're, I don't know, your superclass is books, for example, then you may have subclasses, novel and I don't know, non-fiction book or other book types. That would make sense to me in the sense of an inheritance relationship. A mixin is different. A mixin is more has a kind of relationship. So in this case, what it looks like this is that the redirect mixin supplies redirect functionality to a session. But most often, actually, if you have a mixin like this, most often you can solve this by composition. Because there's several problems. You can also see it here, that the redirect mixin, it calls a send method. But the send method is defined in the subclass. It's defined in the session class, which uses the mixin. So there's a really weird kind of relationship between these two classes because of the mixin mechanism. Because session depends on functionality that's available in session direct mixin, right? It's a subclass, so I'm presuming that it's going to use these things like resolve redirect. Can we find this? We can probably find this. Is that here maybe? Is that in the, yeah, so that's in the send method, and send is in the session class. So send uses resolve redirects, which is defined in the mixin, right? But the mixin calls send. because if I look at the send method, where is it? Oh, here it is. Okay, so the Mixin, I think that's here. This is in the Mixin, right? We're in the Mixin. Resolve redirects. So send, which is in, yeah, so the session that redirect Mixin calls send. Send calls methods from the session redirect Mixin. To me, that's extremely messy. I really don't understand why you would design the code this way, because it's very hard now to understand what is actually going on. And there's no reason to do this. You can actually set it up in a bunch of different ways that are way simpler. For example, you could keep the session redirect Mixin class, but wherever you call the send method, so that's in line 265, so that's in the, where is it? In resolve redirects, yeah. So you could, if you really wanted this to call a send method, you could actually pass that method as an argument. So this then becomes a higher order function, higher order method. And then you could basically store an object of type redirect inside your session class, so that the two classes are basically independent. But because session redirects Mixin, it's typical of Mixins actually that they typically don't store state, otherwise that results, you get all sorts of weird behavior. That in many cases, you could actually take this whole class and just turn this into a bunch of functions, right? I mean, take a look at this. Get redirect target, right? So it gets something called resp. I'm not sure what that is supposed to be. So that's some sort of object that has a property is redirect. And then it does, so that's maybe, is that the response perhaps? Oh, receives the response. Oh, I should probably read documentation better. Okay, so it receives the response. And then returns a redirect, URI or none. But if you look at this, this is basically a pure function. Why is this part of a class? Why create this whole complicated Mixin structure if you can just create a couple of functions that do the job? And then you can also write the test for that, because now if you want to test this, you need to create an instance of the redirect Mixin. So, in short, I don't think this whole Mixin setup makes a lot of sense to me. I would, if you really need things to be an object and you want to split things up, I would use composition. So then we would have a redirect object that is part of the session class. So you would have an instance variable, and then you would call methods on that. But here in this case, there is no state that's being stored. So ideally, this whole Mixin setup should be gone. I think it should be in a separate module, and that module should contain just the functions without the selves. Add type annotation so that's clear that this is a response object, and then directly call the functions instead of having the Mixin. So if I were to start refactoring this, that's probably what I would do. And then potentially I would run into all sorts of problems and I would find out why they did it this way, or maybe not. Perhaps I would find that it would be a lot easier by just defining these as functions. So that's my opinion about this and about Mixins in general. I would typically not use Mixins. If you can avoid them, just don't use them. Use composition. It's in many cases it's way simpler. All right. But let me know if you have a good use case for Mixin, or you think we should design this and it should be designed in a different way. Let me know in the comments. Okay, let's see what else we have. Oh, exceptions. That's maybe also interesting to take a look at. Okay, so we have some exception classes here. So there's a request exception, which is a subclass of IO error. Python always makes me laugh. Like, I think it seems to completely mix up errors and exceptions. Some things are called errors, some things are called exceptions. Maybe, I'm not sure what the reasoning is. Maybe you know what the reasoning is. Is it that an exception is always the superclass and then below that are errors. Is that the standard way? But then it looks like it, maybe, but I'm not entirely sure if that's really how it works. I think officially exceptions and errors are actually two different things. I don't think Python is using them in the way that they're supposed to be used. I could actually look it up. Exceptions versus errors. See if we can find out. Yeah, so here you can see that errors indicate unrecoverable system issues beyond program control. Unrecoverable system issues. So that's really something bad happens. That's an error, right? Exceptions represent unexpected events within the program that can often be handled gracefully. That's how I know, that's how I interpret exceptions. So things like there was an issue reading the file. I don't know, some file is missing, or maybe a network connection got closed, or the database offline. You know, that kind of stuff that raises us an exception, then you can deal with it in some way. Errors are probably something worse, maybe, I don't know, segmentation fault or something like that, which is like not really much you can do about except, well, crash, and it's a pity. But if you look at this difference, or at this definition of errors versus exceptions, well, in Python that's not really followed that closely, because actually here there is some JSON error, but that should probably be an exception, right? And why is this is a subclass of IO error, but it is an exception, and then a subclass of that then again is an error. So I don't think request is to blame for this. This is just how it's been done in Python. I really think, yeah, it's a pity that there is this inconsistency. It would be better if Python simply used exception everywhere, or if they want to error everywhere, just pick one and be consistent about it. What's good about this file though is that there is a request exception. So there is a hierarchy of a request exception. This is the base class for that. And then we have a bunch of subclasses. So there is an invalid JSON error, that is a request exception. And there is a JSON decode error, which is a subclass of multiple other classes. I'm not sure why we should have multiple inheritance here. To me, that doesn't make a lot of sense. That doesn't make a lot of sense to me. So I wouldn't set it up like this. I would really consider it a tree and not have these multiple inheritance things. But well, we've also seen that with the Mixin part. DRMR says, I don't think request is going to refactor much anytime soon, considering the amount of project depending on it. I totally agree. Actually, I don't expect them to do much refactoring at all, especially since I feel like request is a bit on the decline, and perhaps people are switching to other types of libraries like HTTPX, which are a bit more modern. But I think it's still interesting to look at the design and see how everything is set up in a lower level library like this. So anyway, so we have all these different subclasses. That's actually nice if a package does that, because then you can actually catch all the exceptions belonging to a particular package and then do something with that, which is nice. However, I don't really recommend this kind of multiple inheritance in your exception hierarchy, because it's kind of unclear what kind of error it then is. Is the value error or request exception? Why not? Why do that? To me, it doesn't make a lot of sense. Okay. So I think we can spend still a lot more time here. But before I close the live stream, I also want to take a look at the test and see if we can see some interesting things there. So let's see. We've looked at adapters. So how is that actually being tested? It seems not a lot. Okay. So there's a single test here for the adapters, which is that. Okay, so we're getting some local hosts. And it seems the only thing it's tests is that it trims the leading path separator. Okay, that's very limited. How about the rest? Is there a sessions test? No. Okay, this one. This seems like it should contain lots of tests, right? Okay, it's pretty large, so that's a good thing. So how does this actually work? Okay, so an interesting thing is there is a test server file, or a package actually. So let's see, that's part of the test. Let's see what that actually does. Okay, so this is a dummy server used for unit testing. Localhost, okay. So it seems to work with a socket. And it seems to just send back a 200 OK with the length of the content and the arguments. So this is pretty basic. So this is what's being used in the test. I think it's a nice example of what you need to do in order to write a unit test. There's often a lot of this kind of boilerplate code that you need to do, especially if in these types of libraries, because, well, you have to mock out the actual server, right? And then you have to do it in a way so that you don't actually create an actual connection. So that's always interesting. I do think that the requests code could use a bit more abstraction in this sense, because now, yeah, there's it's really just objects. There's no abstract base classes. There are no protocols. That may be, again, for compatibility reasons, but it's still would be nice to have that. So then let's take a look at test request again. Okay, so this creates the test server. So think one issue, and I think that's also what you see here in the test. So they use PyTest. Okay, that's interesting. Nice. Yeah. One thing that's I think this shows is, if you look at this file, this is huge. Now, typically, you would actually, it's actually good practice to have your test folder structure follow the same structure as the actual source code. And I think that's also what you see here. So we have request structures, packages, low-level adapters. So we also have that in the source folder. Yeah. So when I look at the organization here, it seems like there is a sort of mapping between what you have here and the tests folder. So that seems to be roughly the same. I do see some differences. For example, I don't think there is also a low-level file in the source code. But what I do think is that if you have, like, if we go back to the source code again and we take a look at the at these files, so one difference that you see in the test folder is that there is a test request which seems to test basically everything. So I think this should be split up into what this actually tests, because now it's not really clear to me. So, for example, here, this tests the request class. So it just creates the thing, and then it checks that this is not in the headers. So I think this should be in a file that's basically related to where this is defined. And that's in, where is that? That's in models. So I think there should be a models file where this is being tested. Is there a test models? There is no test models. So that's kind of confusing to me, because that means that the way that the tests are organized is different from the way that the source code is organized. So then tests for your source code are going to be harder to find. So whenever you have your test set up, try to let it follow as closely as possible your actual source code. Macon says if you press dot, it opens VS Code. It does? Ah. It does something. Ah, that's interesting. I didn't know that. Okay, well, this is actually a bit harder to read, I think. So I'll stay in GitHub. It's maybe a bit better. But any case, overall, if you set up tests, like I said, try to follow the same structure as your main source code. It's going to be easier to manage. And then you can also more easily see if you wrote tests for that specific part of your source code, because currently you can't really see that from the file structure here. Now, obviously, if you do things like a coverage test, for example, then you will see it then, but still I think it's good practice to have your source folder and test folder follow the same structure. What's also interesting here is that there is a test for the test server. That's actually kind of funny. But that is the kind of thing you need to do, because if your test server doesn't work as you expected, then the tests that use your test server potentially also fail. So we have a sort of a meta thing going on here. That's very interesting. Okay, so overall, when I look at the kind of things we've seen in the source code, I think there were, in some ways, I think the way that inheritance is used doesn't make a lot of sense to me. There were quite a few mixins that I think should be avoided, can be replaced by composition. I think the library could rely more on functions and less on classes. Split things up more into smaller modules. Make sure that the tests are organized in the same way as the source code. So I think for me those are like the main things that I've noticed. Let me know in the chat if you noticed anything else in this particular code. If there's something that you think is weird, or that you noticed while you were browsing through the source code, let me know in the chat. And what I'm going to do now is I'm going to create a poll, and then I'm going to let you rate this library in terms of design. So while I write that poll, if you have any questions for me about the request library, but perhaps you have a few other things you would like to ask me, just post your question in the chat. And then to finalize this live stream, I'm going to go through as many questions as possible and answer them. So post them in the chat. And I'm going to create the poll now. Okay, I already see an issue here. I'm not able to create a poll with more than 4 options, but let's do 4 options. So 4 is the best design ever. So give your rating. What do you think? A 1, a 2, 3, 4? It's going to be interesting. Okay, DRMR ask, is there automated CI setup? Actually, let's take a look if there is something here. So that should be normally at the top level. So we do see workflows here. So yes, there's definitely something here. There's automation for closing issues. That's nice. Automatically close a bunch of issues. Okay, so all off-topic things are closed automatically. Those kind of things. That's nice. Is there a... there doesn't seem to be an automation that automatically publishes it on the Python repository or something like that. Let's see, there is an analysis. What is this? CodeQL. Okay, so this scans for certain things. So there's that. What else do we have? We have linting. Honestly, I think this is nice, but it should just be part of the overall settings. And what else do we have? Log issues. Okay, this is also issue related. Okay, so if it's inactive, then it's going to log them. That's fine. And we have running tests. Okay, so whenever we do a push or pull request, then it actually runs the tests. And does it actually run all the unit tests? Is that what it does? Make CI, let's see. So then we have the make file that contains, the actual things that need to be run. So this is basically what's being run. So there's the test that's being run whenever you push a new version. So that's nice. Yeah. Okay. Yeah. And so, oh, there's also a publication here. Yeah. So this this uses setup.py. Yeah. Yeah. Okay. And then this might be called somewhere from the GitHub workflow, I guess. But I didn't find that. That wasn't here. No. Okay. So that might be called somewhere else, or maybe they do it manually. That's also possible. Yeah. 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 Okay, so let's see how far we are with the polls. There's 25 votes. I see there's over 100 of you in the live stream at the moment, so please, please vote. Let me know your thoughts. What do you think of the design? So 8% says really bad. 32% rates it with a 2. And half of you currently rate it as a 3. So that's actually pretty good. I think you're being really kind today. Yeah, so Jona says using Docker Compose could be a nice improvement for testing in local NCI scopes. Yeah, absolutely. I think Docker could be nice here. Yeah, especially if you want to test a web server. Yeah, totally agree. I don't think I can vote myself. I would probably vote it maybe a 2, not really a 3. But overall, you do seem to rate it pretty okay. So that's actually not bad. Yeah. Okay. Thomas asked a question. Do you know any repositories that contain configurations across different environments? Unit testing, integration, production, with an easy way to switch between them. I don't know of any specific repositories like that. Maybe somebody knows something. We do have, for some of our own projects, we have different workflow files for the different setups. Actually, what we typically do is that we have a different workflow file for each area of the project. Maybe can I show maybe something? Just give me a minute. I'm not sure I have that here, but let's see if I can copy over something. Okay. So here, so we have this tool called LearnTil, which is a quiz generator for, I don't know if you tried it, but if you go to learntil.com, you can try it. It's free. You can basically enter a topic and then AI is going to generate a quiz for you. You can take the quiz, you get a score. It's a lot of fun. But we have backend and front end, obviously. So the backend is written in Python and the front end is written with React. And what we do is that inside our repository, we have we have different folders for it. So I won't show you the complete repository. It's a bit messy, but just want to show you the workflows quickly. So for example, this is the backend Docker build. So this basically, whenever you push to the main branch, so that's the production version of the backend, and then if the backend slash whatever path is changed, or if the workflow itself is changed, then we launch this particular workflow. And then there's a couple of things like, okay, what's the project ID, the zone, there are some secrets, and then, you know, we check out the code, we need to authenticate to Google Cloud, then we prepare the environment, so that's basically create setting up the images, things like that. We build the artifact using Docker, then we publish it, and then we deploy it to Cloud Run. So that's the production setup. But for the dev version, we have a very similar setup. So we have a develop branch where we work on new features for LearnTil. And we have that branch for both the backend. We use that for backend development and for frontend. And we have a separate workflow file. That's the one you see here for develop version. So this deploys it to our dev server so that we can see what's going on when we deploy it and we can test it. And this looks roughly the same as the production pipeline, but it's just set up for the development. So we have a different service name, which is the development version of the backend, which in Google Cloud we map to a different URL. And then apart from that, it's basically mostly the same. We just we set up everything. We build the thing, the artifact with Docker. We publish it, and then we deploy it to Google Cloud. So it's exactly the same setup. But this is just the development version, and we only run this when we push to the develop branch. And then we have a similar setup for the front end. So for the front end, this is not in Python, but it works in the same way. So here we have the production version of the front end. So there also we build the Docker file and we publish it and we deploy it to Cloud Run. So all these setups for us, they're very similar because everything is contained in Docker files where we do the specific stuff like installing the right version of Python or installing the node modules in terms of the front end. So having this kind of setup for us works really well. So I don't know if that, hopefully that helps you, maybe gives you an idea of how you could set it up yourself as well. Let's see. All right, so there's now 50 votes. We have 46% says 3 and 30% says 2. So I am going to close the vote and I'm going to give this library a 2.5 as a final rating. It's not great, but there is some, it's not bad either. There's a decent split up in different modules. There is at least tests, so that's not bad, but there's definitely room for improvement. Now, I hope you enjoyed this live stream with me today. It was for me, it was really fun. Taking a look at this library and seeing how that all works, especially since I'm not a network expert or something. So it was kind of interesting. I'd like to know though, do you have any suggestions for how I can improve this format? I'm thinking of doing this more often. Well, first let me know. You can do that in the chat or either as a comment. Do you think this is something you'd like me to do more often? Would you like me to explore more libraries in live streams like this? Do you enjoy this? What can I do to make this better? How can I make this more fun, more interesting, more educational for you? Let me know. Or do you have specific suggestions for open source projects that you'd like me to look into one of these live streams? Let me know in the chat, or if you're watching this offline, just post it as a comment and then I'm going to add it to the list. So thank you very much, Byte Sorcery, for your super chat. That's most welcome. I really hope you enjoyed this. Me personally, I really enjoy doing these live streams. It's it's a bit less structured and organized than the videos where we spend a lot of time doing the scripting and editing and whatever. This is more like a pure way of basically hanging out with you, and I personally really enjoy that a lot. So I hope the coming time I'm going to revisit this series and do more of these and chat with you and take a look at some source code. So this week was a bit special. We don't have a regular video this week on Friday because of the holiday period, everything. But from next Friday, there's going to be more videos again. And like I mentioned, in a few weeks, I'm going to do the major updates to the Software Designer Mindset course. You can still get in at the current price for a couple of weeks, but after that, the price is going to increase and you're going to get access to all of those updates. So if you want to join, go to ArjanCodes/courses/TSDM. Thank you so much for joining the live stream today. Really enjoyed being here with you today, and hope to see you soon. Bye-bye.